Hi, in this video we are going to talk about long division. So before we actually talk about long division of polynomials, before we talk about long division of polynomials, I want you to think back to when you first learned how to divide. And so we're going to go through the process of dividing 3,124 by 3. And so how did you divide this? So by hand, not by calculator. When you first learn how to divide, old school way of division, there are a lot of different new methods now. The first thing you were told to do was ask yourself, how many times does 3 go into 3? Well, 3 goes into 3 one time. You will write the 1 on top. Then you will multiply the 3 times the 1, and that's 3, and you will write underneath there. Once you write it underneath here, you will subtract, that's 0, and then you will drop down the next number, 1. And you would say 3 goes into 1, how many times? Well, 0 times. It don't go into 1. So you do 3 times 0, which is 0, subtract 1, then drop down to 2. How many times does 3 go into 12? 3 goes into 12 4 times. 3 times 4 is 12. That's 0. Drop down the 4, and then you will say 3 goes into 4 1 time. 3 times 1 is 3, subtract, and that's 1. And so 1 down here was called the remainder because you have no more numbers to drop down, and this solution up here was called your quotient. What you were dividing by was called the divisor, and this underneath was called the dividend. And so if you wanted to go back and check, or so you will actually write your solution as 1041 and 1/3, 1 over the divisor 1/3. So that would actually be your solution, 1041 and 1/3. So we just divided 3,124 by 3, and we got 1041 and 1/3. And so the way that we checked that was, or the way you can check that is actually multiply 1041 by 3. You get 3 times 1, which is 3, 3 times 4, which is 12, carry the 1, 3 times 0 is 0, plus the 1, 3 times 1 is 3, and then you add the remainder, and the remainder was the 1, and you get 3,124, and that's what you started with. And so that was the way you went back and checked your division to make sure you actually got the correct solution. For example 1, we want to do 6x to the third minus 5x squared minus 3 divided by 3x plus 2. Alrighty, so when we write this out, this will go on the inside, the divisor will go on the outside. So your 3x plus 2 will go out here. But when you write your dividend on the inside, you want to make sure that you have a place for every exponent that's lower than the highest exponent. So your highest exponent is 3. It means you should have an x to the third, an x to the second, an x to the first, and x to the 0. X to the 0 is your constant term. So we have an x to the third, we have an x to the second, but we don't have an x to the first. So we would have to write 0x in its place, and then we have an x to the 0, which is the constant term. So this is how you will write it out. You want to make sure you have a place for every term because it will completely change your answer. And so whenever the first thing you want to do is see how many times does this go into this, and when you do that, you're only looking at this first term here. So 3x goes into 6x squared how many times? Or another way you can ask is 3x times what will give you 6x squared? 3x times, and that should say to the third, sorry, 6x to the third. So 3x times what will give you 6x to the third? And so that will be 2x squared. So 2x squared times 3x will give you 6x to the third. And so just like before in the process, once you figure out how many times this goes in here, you take that and you multiply it by this. So we're going to do 2x squared times 3x plus 2, which means I'm going to distribute this 2x squared and multiply by each of those terms. 2x squared times 3x is 6x to the third, and 2x squared times 2 is a positive 4x. And so just like in the process before, once you put a number or now a term underneath, you subtract it. And so I'm going to subtract this, but I'm subtracting both of these. So that means I do 6x to the third minus 6x to the third, which goes away, and I do minus 5x squared minus 4x. So in it, essentially this negative distributes to both of those. So you can think of, I need to change the sign of both of these. So this becomes a subtraction. So 6x to the third minus 6x to the third is 0. And then negative 5 minus 4 is a negative 9x squared. And just like with the process before, once you subtract, you drop down the next number. Well, in this case, the next term, which is 0x. And then you start that process all over again. So 3x goes into negative 9x squared. How many times? Or 3x times what will give you a negative 9x squared? That would be negative 3x. And then once it's up here, you multiply. So negative 3x times 3x plus 2. Distribute the negative 3x, multiply by both of the terms, and you get negative 9x squared minus 6x. Well, since you're subtracting this, you're going to subtract x. You're going to change the sign on both of those because you're going to distribute the negative. So that becomes negative 9x squared plus 9x squared, which goes away, which should happen every time. That first term should cancel out. And then 0x plus 6x is 6x. And now I drop down the next term, which is minus 3. And start that process all over again. 3x times what will give me 6x? 3x times a positive 2. So 3x plus 2 times 2 is what you want to do next. So distribute the 2, multiply the 2 by each term, and you get 6x plus 4. Since we want to subtract, we're going to subtract, change the sign on both of those. 6x minus 6x cancels. Negative 3 minus 4 is negative 7. So negative 7 is my remainder. So my solution, this is my quotient. So my solution would actually look like this. And I'm going to adjust my camera a little so you can see. So my solution would actually look like this. 2x squared minus 3x plus 2 plus negative 7 over the divisor, which is 3x plus 2. So that would be your solution to that division problem. For example 2, we're going to do negative 5 plus x plus 4x squared plus 2x to the third plus 3x to the fourth divided by x squared plus 2. So my divisor is x squared plus 2, so that's going to go on the outside. And then my dividend is all of this, but when I write it, I want to make sure I write it from biggest exponent to smallest exponent with a place for every exponent lower than the smallest exponent. So my biggest exponent is 4, so I will write 3x to the fourth first. Then I will need a third degree term, which is 2x to the third. Then a second degree, which is plus 4x squared. A first degree, which is plus x. And then a constant term, which is a 0 degree term, which is minus 5. And then I'm going to go through the same process I went through in the last example by starting off asking x squared times what will give me 3x to the fourth. And that will be 3x squared. Now for consistency and alignment, I'm going to write the 3x squared on top of the x squared term. Once I have a number or a term up here, I multiply it by the divisor. So I'm going to take 3x squared and multiply by both terms, the x squared and the plus 2. And I get 3x to the fourth plus 6x squared. And notice I'm writing the 6x squared underneath the 4x squared because I can't combine 6x squared with 2x to the third because the exponents aren't the same. So you want to line them up, make sure you line them up good. And because I'm subtracting, I'm going to change the signs on both of these because I'm going to subtract that. The 3x to the fourth will cancel. There's nothing to subtract from 2x to the third, so I still have 2x to the third there. And then 4 minus 6 is going to be minus 2x squared. And then I'll bring down the x and start that process all over again. X squared times what will give you 2x to the third? That is going to be 2x. So 2x times x squared plus 2 is what I want to do next. So distribute that 2x to both terms. You get 2x times x squared, which is 2x to the third, and 2x times 2, which is 4x. So 4x, I'm going to write it underneath the x because I can't combine it with the x squared. And because I'm subtracting, I'm going to change the sign on both of these. 2x to the third minus 2x to the third, those go away. There's nothing to take away from this negative 2x squared, so just drop down the negative 2x squared. And positive x minus 4x is a negative 4x. And so now I drop down the minus 5 and start that process all over again. X squared times what will give me negative 2x squared? that is minus 2. So I want to do minus 2 times x squared plus 2. Distribute that negative 2. You get negative 2x squared minus 4. Because I'm subtracting, I'm going to change the sign on both of those. 2x squared, negative 2x squared go away. Drop down to negative 4x. No, sorry, I made an error here. 1x minus 4x is not a minus 4x. That should be a minus 3x. Good thing I caught that. Hopefully y'all caught it and was wondering the same thing. So this would be a minus 3x, and negative 5 plus 4 would be a minus 1. So made a little mistake right there, but this is actually a 1x minus 4x, which is a negative 3x. So your solution is this quotient right here. So the 3x squared plus 2x minus 2, and then you have to add your divisor, negative 3x minus 1, over your remainder, over your divisor. So negative 3x minus 1 over x squared plus 2. So this is the solution to that division problem. So you have your quotient plus your remainder over your divisor. So I know it was a lot. Hopefully you can go back and walk through each of the steps. If you have any questions whatsoever, make sure you put them in the comments below. If this video helped you to understand long division, please make sure you like the video, and if you haven't already, hit that subscribe button as well. So thanks for tuning in.